Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the planes. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So here we will be discussing about the projections of the oblique plane, which happens to be inclined with respect to the horizontal plane as well as the vertical plane. Now we have been provided with a regular hexagonal lamina of edge 30 millimeter, which is having a central hole of 20 millimeter diameter. Now the surface of the lamina, it is inclined at an angle of 45 degree with respect to the horizontal plane, while the side on which it is resting onto the ground, it is inclined at an angle of 30 degree with respect to the vertical plane. So we are required to draw the orthographic projections of this lamina. Now we can see that since the surface of this lamina, it happens to be inclined with respect to horizontal plane at an angle of 45 degree. So to begin with, we are going to assume that this hexagonal lamina will be lying onto the horizontal plane. So it will be parallel to the horizontal plane. Now since this lamina happens to be parallel to, or it will be resting onto the horizontal plane, now the true shape of this hexagonal lamina will be obtained onto the horizontal plane, that is in the top view projections over there. And these true shape projections will be drawn below the XY reference line. And when we are going to look at this lamina from the front side, so we are going to observe the edge view projections of this lamina obtained onto the horizontal plane, because this lamina is contained by the horizontal plane. Why? Because one of the side of this particular lamina, it is resting onto the ground. So to begin with, this lamina will be contained by the horizontal plane. Now let us discuss the shape of this particular lamina. So here we have got the shape of this lamina. So the two edges AB and DE, so they happen to be perpendicular to the vertical plane. So the orientation of the lamina onto the horizontal plane has been provided to us. And we also know that the edge length of this lamina happens to be 30 millimeter, and it has got a central hole which is having the dimension 20 millimeter. So this hole is located centrally into this hexagonal lamina. So corresponding to this lamina, when the lamina surface, it is inclined at an angle of 45 degree with respect to the horizontal plane, and this edge AB onto which it is resting onto the ground, so this edge AB is further inclined with respect to vertical plane at an angle of 30 degree. So this way we have to proceed with evaluation of the orthographic projections of this oblique lamina. So to begin with, as we have discussed that this lamina happens to lie onto the horizontal plane. So onto the horizontal plane, that is into the top view projections, we are going to obtain the true shape projections of this particular lamina. So to begin with, we have drawn only the hexagonal lamina without a hole. Let us draw the top view projections and the front view projections corresponding to this hexagonal lamina without the hole. And then we are going to locate the central hole into this particular hexagonal lamina. Now when we are going to look at this particular hexagonal lamina from the front side, now since this lamina happens to lie onto the horizontal plane, so the front view projections, they will be available onto the XY reference line. So the points B and A, they will be projected as B dash and A dash onto the XY reference line. Similarly, points C and F, they will be projected onto the XY reference line as C dash and F dash points over there. And finally, the points D and D, they will be projected onto the XY reference line as D dash and E dash points over here. So this way the front view, which is an edge view projection of this lamina. As we are going to look at this lamina from the front side, they have been obtained onto the XY reference line. Now let us locate the central hole, which is having the diameter equal to 20 millimeter. So in order to locate the center, we have joined the three diagonals of this particular hexagon. So the diagonals CF, BE and AD. So they are going to intersect at this point, which is going to be the center point of this hexagonal lamina. So with this point at the center, we are going to have the radius is equal to 10 millimeter, and this diameter of the central hole, this will be equal to 20 millimeter. So this way the central hole has been located within this particular hexagonal lamina. And then further we have divided this central hole into 8 equal parts in such a way that we are going to get 8 segments over here within this circle, and this each segment, that is between 1 and 2, 2 and 3. So each of these segments, they will be having angles 45 degree each. So each sector will be having 45 degree segment over here. Now this way, the top view projections, which are the true shape projections of this particular circular hole, they have been obtained onto the horizontal plane. So the true shape of this lamina, it has been obtained in such a way that this hexagonal lamina is carrying a central hole having diameter is equal to 20 millimeter. Now having obtained the 8 points corresponding to the circular hole, now these 8 points, they have been projected into the front view projections over here. So we can check point 3 will be projected as point 3 dash in the front view. Points 4 and 2, they will be overlapping. So we are going to get 2 dash and 4 dash in the front view projections. Similarly, points 1 and 5, so they will be again coinciding with each other in the front view projection. So we are going to obtain points 1 dash, 5 dash, and again they are going to coincide with the points C and F over here. So we get C dash, F dash, 1 dash located at the central position over here. So now once we project the points 6 and 8 over here in the front view, we are going to obtain the points 6 dash and F dash into the front view edge view projections of this particular lamina. And finally, point 7 from the top view, once we project it onto the vertical plane, so we are going to obtain point 7 dash onto the edge view projections of this lamina. So this way, the true shape projections of this hexagonal lamina carrying a central hole, they have been obtained onto the horizontal plane below the XY reference line, whereas the edge view projections of this lamina, which is carrying a central hole, it has also been obtained onto the XY reference line. So having obtained the edge view projections corresponding to this hexagonal lamina and which is carrying a central hole, now how many points we have been able to project onto the edge view? So there are 6 points corresponding to the hexagonal lamina and 8 points we have got corresponding to the circular hole over here. So total of 14 points they have been located onto the edge view of this hexagonal lamina into the front view projections over here. Now we know that the surface of this lamina, it is inclined at an angle of 45 degree with respect to the horizontal plane. So now we have to draw an orientation line at an inclination of 45 degree with respect to the horizontal plane in such a way that all of these 14 points which have been located onto the edge view, so maintaining the same distances between the points, so all these 14 points, they will be projected alongside this orientation of 45 degree with respect to the horizontal plane, and we are able to obtain 14 points alongside this particular edge view, which is being carried forward from the previous front view projections which we had drawn earlier. So maintaining the same distances between all these points on the edge view line, so we have been able to transfer all these 14 points in such a way that the surface of the lamina will be inclined with respect to horizontal plane at an angle of 45 degree. Now, having obtained the front view projections of this hexagonal lamina with a hole into the vertical plane, now we have to draw the corresponding top view projections of this particular lamina onto the horizontal plane. That is, the apparent shape projections of this lamina will be available into the top view projections over here. Why apparent shape will be available? Because the surface of the lamina has been inclined at an angle of 45 degree with respect to the horizontal plane. So how do we obtain these plan projection points corresponding to this apparent shape of the lamina, which is inclined to HP? From all these 14 points in the front view, we are going to draw the vertical projector lines, and from all the 14 points of the previous plan projection view, we will be drawing the horizontal projector lines into the plan projection view over here. And once we draw all of these vertical projector lines and the horizontal projector lines, so the intersection of the corresponding projection lines, they will provide us with the availability of each one of these plan projection points available to us into this particular projection view over here. Now here we can see, first of all, we are going to obtain plan projection view corresponding to the hexagon. Then we are going to obtain the projections of this particular central hole over here. So this central hole will be projected as an ellipse in the top view projection. So let us start with the external boundary, that is regarding 6 points of the hexagonal lamina. So once we draw the vertical projector through the point F1 dash and we draw the horizontal projector through the point F, so wherever these two projectors they are going to intersect, we obtain the location of the point F1 over here. Similarly, through A and E, we have drawn a horizontal projector line, and let us see where does this horizontal line it intersects with the vertical projectors drawn through the points A1 dash and E1 dash over here. So we can check this horizontal line drawn through the projectors A and E, it intersects with vertical projector drawn through the point A1 dash at this position. So here we are able to locate the intersection point of this vertical projector line through A1 dash and the horizontal projector line which has been drawn through the point A. So we are able to locate the point A1 over here. Similarly, through the point E1 dash, we have drawn a vertical projector line and extended it up to the limit where it is going to intersect with the horizontal projector line drawn through the point E. So this intersection point has been obtained as E1 over here. Similarly, from B and D, we have drawn a horizontal projector line, and we'll see that how does this horizontal projector line it intersect with the vertical projectors drawn through the point B1 dash and D1 dash. So we can check from B1 dash, if we draw a vertical projector line, it is going to intersect with this horizontal projector line drawn through the point B. So we obtain the point B1 over here. Similarly, from D1 dash, we have drawn a vertical projector line in the downward direction, and at this point, it is going to intersect with the horizontal projector drawn through the point D over here. So this way, point D1 has also been evaluated. And finally, from point C, we have drawn a horizontal projector line and it intersects with the vertical projector line drawn through the point C1 dash at this position. So this way, all the 6 points corresponding to the boundary of this particular hexagonal lamina, they have been evaluated. So if we are going to join A1, B1, C1, D1, E1 and F1, so we are going to get the apparent shape of this hexagonal lamina, which happens to be inclined with respect to the horizontal plane at an angle of 45 degree. Now let us evaluate the location of all the 8 points corresponding to the circular hole into the apparent shape projections over here. So once again, we are going to draw the vertical projectors through all of these 8 points of this circular hole from the front view projection over here. And let us find out the corresponding points of intersection with the horizontal projectors which we are going to draw from the 8 points of the plan projection view which we had drawn previously. So now we can see 3 and 7. These are the 2 points which are going to yield single horizontal line. So this is the single horizontal projection line which we have drawn through the points 3 and 7. So let us evaluate the location of the vertical projectors which will be drawn through the points 3-1 dash and 7-1 dash. So 3-1 dash point lies here. If we draw a vertical projector downwards, we find that the intersection of this vertical projector drawn through the point 3-1 dash with the horizontal projector drawn through the point 3 of the plan projection view, it occurs over here. So we obtain the point 3-1 at this location. Similarly, the vertical projector drawn through the point 7-1 dash. So once you extend it downwards, so at this point, it is going to intersect with the horizontal projector which has been drawn through the point 7 of the plan projection which we had drawn previously. So 3-1 and 7-1 points, they have been located. Similarly, now we can check that if we draw the horizontal lines through the points 2 and 8, so this horizontal line corresponds to the points 2 and 8 of the plan projection view. So if I draw a vertical projector line from the point 2-1 dash which lies over here. So if I draw a vertical projector in the downward direction, it is going to intersect with this horizontal line emerging through the point 2 at this position. So I am able to obtain point 2-1 over here in the plan projection view. Similarly, I have drawn a vertical projector through the point 8 dash over here. So once I draw this vertical projector through the point 8-1 dash over, it is this projector line. It is going to intersect with the horizontal projector drawn through the point 8. So I obtain the point 8-1 over here. Similarly, 4 and 6. So these 2 points in the plan projection view, they have been projected horizontally towards right through this projector line. And once I draw the vertical projector from the point 4-1 dash, 4-1 dash point lies over here. So once I draw this vertical projector line through 4-1 dash, so we will find that I am able to obtain the intersection of the vertical projector through 4-1 dash with the horizontal projector drawn through the point 4. So this point of intersection provides us with the point 4-1 over here. And similarly, we have drawn a vertical projector through the point 6-1 dash. So this point is 6-1 dash. So through this point, once we draw a vertical projector, so we are going to get the intersection of the vertical projector drawn through the 6-1 dash and the horizontal projector drawn through the point 6. So this point will be obtained as 6-1. So now further, we are required to evaluate the location of the point 1-1 into the plan projection view. So we can check from point 1, we have drawn a horizontal projector into the plan projection view, and let us see where does it intersect with the vertical projector line drawn through the point 1-1 dash. So this point is 1-1 dash. So from this point, when we bring the vertical projector in the downward direction, we will see that the vertical projector drawn through the point 1-1 dash, it is going to intersect with horizontal projector drawn through the point 1 over here. So this provides us with the location of the point 1-1 in the top view projection. And finally, we have to draw the projections corresponding to the point 5. So please check, this is horizontal projector drawn through the point 5. It intersects with the vertical projector drawn through the point. This is point 5-1 dash over here. This projector has been drawn through the point 5-1 dash, and once you bring this down, it intersects with the horizontal projector drawn through the point 5 over here. So this is the location of the point 5-1. So this way, all the 8 points corresponding to the circular hole, they have been appropriately located into the plan projection view. And this circle will be appearing like an ellipse in the top view projections, so which is again an apparent shape. And similarly, this hexagonal lamina has been squeezed. It is appearing as a squeezed hexagonal shape because of its inclination with respect to the horizontal plane. So these apparent shape projections of the lamina have been obtained by virtue of the rotation of this hexagonal lamina with respect to the horizontal plane at an inclination of 45 degree. Now, in the second instance, we have been provided with the information that's the side on which the lamina is resting onto the ground. Which side is this? It is this side, AB. So A1 dash, B1 dash points, they lie onto the horizontal plane. So this particular edge, it is further inclined at an angle of 30 degree with respect to the vertical plane. So we have to rotate or transform this particular apparent shape of the lamina in such a way that this edge A1, B1, which happens to be the true length. Why this is true length? Because this edge, it is lying onto the horizontal plane. So it is parallel to the horizontal plane. So edge AB, since it is parallel to the horizontal plane, so on the horizontal plane, we have been able to obtain the true length of this particular edge over there. Now, this edge has to be realigned at an angle of 30 degree with respect to the vertical plane. So now we have to redraw this apparent shape of the plan projection view at an angle of 30 degrees such that we can place this edge A1, B1 alongside this orientation line. So we can inscribe this hexagonal lamina into the rectangular shape over here, and this rectangular shape we have translated over here into the plan projection view. Now different points we can locate using the rectilinear distance method. Now we can check how many vertical internal projector lines they will be there. So number of total projector lines will be 1, 2, 3, 4, 5, 6 and 7. You can see 5 lines we have drawn corresponding to these points and another couple of lines now we are going to draw. You can check. Now total of 7 projector lines which are lying in this perpendicular direction. 1, 2, 3, 4, 5, 6, 7. So these are 7 vertical lines. You can see 1, 2, 3, 4, 5, 6 and 7. And now once we draw or locate these lines with respect to the distance either from this edge or this edge of the rectangle, now we need to draw 5 horizontal lines over here. So you can check, this is horizontal line 1, horizontal line 2, 3, 4 and 5. So once we draw these 5 horizontal lines, how we can draw them? We can mark the distance of first line from this edge, second line, third line, fourth line and fifth line. And we have to mark the appropriate points according to wherever they are going to lie. We can check 1 point, this will locate A1. Second point, this will locate distance from this one, this will locate B1. Similarly, this distance will locate D1 over here. This distance will locate E1 over here. This distance will locate F1 over here. This distance over here will locate C1. So similarly, the internal points corresponding to this ellipse, they will also be located into this transformed figure. So once we mark all of these points, you can see 8 points corresponding to the hole they have been marked from this figure, and 6 points corresponding to the external hexagonal lamina they have been marked over here. Using the rectilinear distance method, this is the apparent shape of the lamina which we have obtained over here. And please check this figure and this figure, they are the same. Only thing is, into this view we have rotated this apparent shape in such a way that A1, B1 will be aligned at an inclination of 30 degree with respect to the vertical plane. Now having obtained the plan projection view over here in the horizontal plane, now we are going to obtain onto the vertical plane the apparent shape of this hexagonal lamina along with the hole in such a way that the corresponding points we are going to obtain corresponding to the 14 points over here. So corresponding to these 14 points which are located in the elevation view, horizontal lines we are going to draw. Corresponding to these 14 points over here in the plan projection view, the vertical projectors will be drawn, and the intersection of the corresponding points, they will help us to obtain the elevation projection points corresponding to this hexagonal lamina carrying a hole over here. Now we can check from A2, we draw a vertical projector. From A1 dash, we have drawn a horizontal projector. The intersection point provides us with the location of the point A2 dash. Similarly, from B2 in the plan, we have drawn a vertical projector upwards. From B1 dash in the elevation, that is this point, we have drawn a horizontal projector line, and the intersection of these two projector lines has provided us with the location of the point B2 dash in the front view. Similarly, C2 dash point has been obtained in the front view by virtue of intersection point corresponding to the vertical projection line emerging from C2 and horizontal projector line emerging from point C1 dash of the elevation. Similarly, you have got point D2 dash. So D2 dash, it is the result of intersection of the vertical projector line drawn through the point D2 of the plan and horizontal projector line which has been drawn through the point D1 dash of the elevation. Similarly, from E2 we have drawn a vertical projector line, and from E1 dash we have drawn a horizontal projector line. So wherever these two projection lines they intersect, we have obtained the point E2 dash over here. And finally, regarding the external boundary of this hexagonal lamina, from F2 we have drawn a vertical projector line upwards, extended it up to the limit where it is going to intersect with horizontal projector line emerging from the point F1 dash. So all the 6 points of the hexagonal lamina, they have been obtained. So this is the apparent shape of the hexagonal lamina, which is an oblique lamina inclined with respect to HP as well as with respect to VP. Now let us locate the central hole over here. So similarly, from all the 8 points, we are going to draw vertical and horizontal projectors and find out the corresponding points of intersection. So we can see 7-2 dash. It has been obtained from the intersection of vertical projector through 7-2 and horizontal projector drawn through 7-1 dash. Similarly, next point we have got 6-2 dash. You can check vertical projector through 6-2 has been obtained and horizontal projector from 6-1 dash has been obtained. So wherever these two intersect, we have been able to obtain the point 6-2 dash over here in the front view. Similarly, this is the horizontal projection line corresponding to the point 8-1 dash, and this is the vertical projector line starting from the point 8-2. So this way 8-2 dash point has also been located. Next, you have got this point. It is the location of 1-1 dash and 5-1 dash. So corresponding to 5-1 dash, this is the horizontal projector line starting from the point 5-2. This is point 5-2 of the plan. You take the vertical projector upward. So this intersection of these two projection lines provides us with the location of the point 5-2 dash. Similarly, here we have got vertical projector drawn through the point 1-2 from the top view, and this is the horizontal projector drawn through the point 1-1 dash. So this intersection of these two projection lines has provided us with the point 1-2 dash in the front view projection. Next, you have got the point number 4. So from the point 4-2 of the top view, we have drawn a vertical projector line upwards, extended it up to the limit where it is going to intersect with the horizontal projector line which has emerged from the point 4-1 dash. This is 4-1 dash, this one. So from here we have drawn a horizontal projector line. So this intersection point is the location of the 4-2 dash point. From the point 2, that is 2-2 over here. So we have drawn a vertical projector line moving upwards. From 2-1 dash we have drawn a horizontal projector over here, and the intersection of these two projection lines has provided us with the location of the point 2-2 dash over here. And here we have obtained 3-2 dash point as an intersection of the vertical projector through the point 3-2 and the horizontal projector obtained through the point 3 1 dash. So this is the point 3 1 dash. So through 3 1 dash we have been able to obtain this horizontal projector. So this way all the 8 points which correspond to an elliptical projection in the front view projection, they have been obtained corresponding to the central hole. So this way the apparent shape of a hexagonal lamina carrying a central hole, they have also been obtained over here. So now using the basic fundamentals of the projections of the planes, we have been able to evaluate the orthographic front view and top view projections of an oblique regular hexagonal lamina which is carrying a central hole, and this lamina happens to be inclined with respect to the horizontal plane at an angle of 45 degree, and with respect to the vertical plane it is inclined at an angle of 30 degree. So this is all for today. So I hope that through this discussion you would have understood about the procedure to evaluate orthographic projections of a lamina which happens to be inclined with respect to horizontal plane as well as the vertical plane. So we'll be continuing with further discussion regarding few more illustrative cases of the orthographic projections of the planes in the coming lectures. So thank you very much. Thanks a lot.